This video is on matter and its properties. It's a continuation of our discussion on matter and what matter is, and getting a little more detailed into properties of matter. So the first thing we're going to talk about is that there are two ways to designate certain types of properties of matter, and they are extensive and intensive. So an extensive property of matter depends on the amount of matter that is present. Okay, so extensive property is a property that depends on how much matter there is. So an extensive property, an example would be mass or weight, right? It's going to depend on how much matter there is based on the weight of something or the mass. Another one is volume. Right? Do you have a little bit of water or a lot of water? Reading the volume of that water would change based on how much matter was there. Another one that we don't really deal with a lot in chemistry initially is energy. Okay, but the energy that is associated with something also depends on how much matter there is. You can kind of think about, we eat food to give us calories, which are energy, okay, to give us energy. So technically the more you eat, the more energy you have. So it depends on how much matter there is. Or you might guess that opposite of extensive is intensive, and intensive properties do not depend on how much matter there is. And there's kind of a caveat here that intensive properties do not depend on how much matter is in a sample, only on the identity. Of the substance. Okay, and we'll talk about that in our examples. So what's an intensive property then? Well, an intensive property would be temperature. So think about this. You fill up a small cup of water and a huge bucket of water and leave them overnight, and you come back the next day and take their temperatures. Well, assuming they sat in the same room all night long, those two hugely different amounts of water should have the same temperature. It doesn't matter. So temperature is a really good one. Boiling point. And then along with boiling point would be melting point. Okay, so the temperature at which something boils has nothing to do with how much matter is in that sample. So the temperature that water boils at, 100 degrees Celsius, water always boils at 100 degrees Celsius, regardless of if you have a small cup of water or a huge, like soup pot of water, okay? So boiling point and melting point are independent upon how much matter there is, but they are dependent on the identity, right? Water boils at a different temperature than, say, some like rubbing alcohol, okay? Those are two different things, and that's why they boil at two different temperatures. Another good one that we've just talked about is density. Okay, the famous example with density was you have a bar of gold, you cut it in half, what's the density of each piece, right? It's a trick question because density doesn't change. Density is a ratio of mass to volume, which is interesting because mass and volume are extensive properties, but density is an intensive property, right? So gold will have the same density no matter what size it is. So that's the difference between extensive and intensive properties, and we're going to move on to states of matter. This is something that you should have had, for years and years in science class. So we're just going to move quickly through the three states. All right, so solids, they have a definite shape and a definite volume. Their particles are packed closely together. And if I had to draw a solid, it would kind of look like this. Right, all those particles packed in this fixed position in my solid. All right, liquids. Liquids have a definite volume. right? Think about water in a graduated cylinder. You could read the volume of the liquid, but they take the shape of their container. Right, if you put water in a graduated cylinder, it takes a cylindrical shape. If you pour water into a cookie sheet, right, it spreads out into the rectangular shape of the cookie sheet. All right, so liquids take the shape of their container. Their particles are fairly close. But move past one another. And it's actually why liquids are given the word that they flow, because their particles kind of flow past each other. So if I was to draw a liquid, particles are close, but there's definitely room still in between. Now a gas takes the shape and the volume of whatever container it's in. Think about a balloon. Right? When you blow carbon dioxide into a balloon, your carbon dioxide fills the balloon to take the shape of the balloon, and also it fills it to take up the whole volume of that balloon. There is lots of space between the particles, and that is why gases are said to be easily compressed. Okay, you can squeeze those particles together to alleviate some of that empty space. So if I were to draw a gas, it looks something like this. That should be a very quick review in the 3 states of matter that you have seen numerous times. All right, onward. We're going to talk about physical properties. So physical properties are characteristics that can be observed or measured without changing the substance's identity. Okay, so I know I'm not holding anything up in front of you, but just imagine that I had a piece of printer paper, okay? So we could identify some physical properties about that piece of computer paper, and those would be properties that we could observe or that we could measure without changing the identity of that paper, okay? Leaving the fact that it's just paper. So you might say it's white. So color is a physical property. You might say it's flat or it's a rectangle, okay? So shape is a physical property. Somebody might say it's smooth. So texture is a physical property. And then we can also talk about properties we measure. So you could measure its mass. You could measure its volume. So those are all physical properties of a substance that you can observe or measure without doing anything to affect the identity of the substance. We could talk about all kinds of things. You could talk about an apple, right? So physical properties of an apple are that it's red, it's round, it has seeds on the inside. Those are all physical properties. So now we're going to talk about physical changes, and they are a change in a substance that does not involve a change. Man, I keep doing that. Change in the substance's identity. Okay, so now we're talking about changes. So if we go back to our piece of paper, that piece of computer paper, we want to talk about how might we change it, but we can't change the fact that it's paper. Okay, so you could tear it in half. You could cut it apart. You could shred it. You could color on it, draw on it. You could fold it. Okay, if we go back to that apple example, what could you do to the apple? You could cut it in half. You could peel the skin off of it, right? It's still an apple. You could even take a bite out of it. It's still an apple, okay? So those are physical changes. Changes in a substance that do not involve a change in the identity. A big one that I want to add to this is changes in state of matter. And what I mean by that is the states of matter we just talked about, like taking a substance that's a solid and turning it into a liquid. Well, that's the process of melting. So if we talk about an ice cube, for example, which is solid H2O, and I were to melt it, well, it's going to look different, but it's still H2O. It's just in the liquid form. So because the identity of the substance has stayed the same, that's a physical change. So if melting is a physical change, so is boiling, okay? And then the reverses of those processes are also true. Freezing is a physical change, and so is condensation, gas going to liquid. Okay, those are all physical changes. The identity doesn't change. The look of the substance might change, right? An ice cube definitely changes its appearance when it melts, but it's still H2O. Okay, and then the last thing we're going to talk about are chemical properties and chemical changes. So this is a little bit different. Chemical property is a property of a substance, that allows it to undergo a chemical change. This is kind of a weird definition because I'm kind of using the chemical change in the chemical properties. So anyway, so if we're talking about, let's talk about that apple again. If you leave an apple in your refrigerator for way too long or on your counter for way too long, it starts to rot or it starts to decompose. That is a chemical reaction, which is what we're going to talk about in a minute. But the ability of that apple to rot or the ability of that apple to decompose is a chemical property, because once rotting or decomposing happens, it's not really an apple anymore. There's been some kind of chemical reaction. So if we go back to that paper, this is everybody's favorite chemical property of paper, is that it's flammable, right? And it can burn. So flammability is most definitely a chemical property, because when things burn, they actually undergo a chemical reaction. So that's our last part of this lecture, is what is a chemical change or a chemical reaction? And it's a change where one or more substances are converted into new substances. Okay, there has been some kind of change in identity. Whereas in a physical change, there was no change in identity, right? So what are some chemical changes? Burning, rusting. Okay, metal rusting is actually a chemical reaction. Decomposing, which we already talked about. Those are most definitely chemical changes or chemical reactions. So the only other thing I want to talk about here is what a chemical reaction looks like. So when we start talking about reactions, we might have two substances and they combine to form a third substance. Okay, so this is the way chemical reactions will look. The starting materials are called the reactants. That's what you begin with. They're always on the left side of the arrow. The thing you end with, and sometimes there's two, sometimes there's one, are called the products. That's your end result. right? And the arrow means yields, which really means to make or create. So this is what chemical reactions look like when we get this far. Probably the simplest chemical reaction maybe that you know of, excuse me, is baking cookies. It's a silly example, but it works. So your reactants, in that case, your starting materials would be sugar, flour, chocolate chips, butter, eggs. Okay, so in that case, there's a lot of reactants. And then you would yield, or you would create your product, which in this case would be chocolate chip cookies. Okay, so that's a chemical reaction. And we'll be studying chemical reactions in much more detail, along with how do we know a chemical reaction has happened in our next